Hello everyone, this is J. Kiran, first year BE Mechanical Engineering Department. Today, my case study is on the topic Validate Newton's Law of Rotational Motion in Spinning Top. We all would have played using the spinning top in our childhood, but we never realized how much advanced physics is involved in understanding the motion of spinning top. While the spinning top may seem very simple, but the rotation motion of spinning top actually involves higher concepts of mathematics and physics which is more complex to understand. The spinning top involves angular momentum, inertia, torque, gravitation and air friction and several other concepts of physics. A force is applied to start the spinning top that converts the potential energy into kinetic energy. The spinning top achieves angular momentum after initiating by a source torque. The top will remain spinning until an outside force disturbs its spinning motion. Now, let's understand the problem of spinning top. Initially, it stands vertically and rotates about its own axis, but when it is slowing down, it starts wobbling. A new kind of motion is generated, the precision motion or the nutation motion, which rotates around this axis, which is also known as the precessional axis. To understand the mathematical solution of precessional motion, first let's understand the working of spinning top. To make the top spinning initially, a to make the spinning top initially a source torque is applied that converts the potential energy into kinetic energy. As it begins to spin around its axis of rotation, an angular momentum is generated. The angular momentum remains unchanged until it is acted by another external force. The law of conservation of angular momentum helps to validate the Newton's first law of motion. When the external force such as friction or gravity acts on the spinning top, it changes the angular momentum, thus making the top to slow down or to begin wobbling. Now, the spinning top shows precessional motion, that is the rotation around the another axis. Here we can see this is the axis of rotation of the top and this is the another axis which is also known as the precessional axis. Now the spinning shows precessional motion, that is rotation around the axis. The torque due to the weight of the top causes tilting, allowing the gravity to pull down the top. Gravitational torque causes the top spins in a precessional axis and the top continues to slow down, wobble and eventually falls and it stops. Now let's understand the physics of rotation of the spinning top. Initially it stands vertically and rotates about its own axis, which is also known as the self-spinning axis. This is the self-spinning axis and this is the precessional axis. After a while the angular velocity of the top reduces and bends due to its own weight and shows another rotation about another axis. That is the rotation of self-rotation axis is called the precessional motion. So there are two types of rotational axis. One is the self-rotational axis and the other is the precessional axis. Here we can see the validation of Newton's second and third law. Due to the gravitational force, a torque acts on the top that leads to the precessional motion. As long as speed is higher in rotating in self-spinning axis due to the high kinetic energy. As the speed decreases, kinetic energy decreases, due to which the gravitational force is pulling the top towards the ground and the Earth's gravitational force dominates. Due to the gravitational force, a torque acts on the top that lead to the precessional motion. Here we can calculate the angular momentum. Wp represents the angular momentum. Here we have between the self-spinning axis and the precessional axis, the angle is taken as phi, which is given by the change in linear momentum by the component of the linear momentum, that is L sine phi. Here omega p is given by delta theta by delta t and is replaced by change in linear angular momentum by the component of linear angular momentum multiplied with respect to time, which gives the tau by L sine theta, and we get the formula omega p is equal to mgr by I omega. Here precessional angular momentum is inversely proportional to the spin angular velocity. So the precession is faster and the top slows down. As the spin slows down, the precession becomes more faster and faster, and slowly the top wobbles and falls down. So now to check and validate Newton's law, let's consider the top spins in outer space. In this case, inertia is not applicable. Then some force must be constantly applied to keep the top in accelerated motion. But the force is applied only at the time of spinning. So why does it spin? Thus, Newton's third law says that the force act, acts in pair. Thank you.